Hi everyone, welcome to Rare Pearl Online Edu class. In this session, I'm going to solve problems on potential difference and work done. We are going to see various expressions for potential difference. So from the definition of electric potential, we get the expression V is equal to W by Q. And the second expression V is equal to I into R is got from Ohm's law. And third expression V is equal to P by I is obtained from the expression of power which we have already discussed. We know the SI unit of various quantities. Charge is Coulomb, voltage volts, current ampere, resistance ohms, work done joules, and power watts. Let's see the first problem. Calculate the potential difference between the two terminals of a battery. We need to find the potential difference of this battery, that is the voltage. If 100 joule of work is required to transfer 20 coulomb of charge from one terminal of battery to the other. So the amount of work done is 100 joule in bringing the charge from the negative terminal of a battery to positive terminal. Okay. So what all the data is given? W and Q is given. And we need to find what is the potential difference. The relationship between V, W and Q is given by V is equal to W by Q. On substituting the values of W and Q, we get 100 by 20. Okay. And we know that V is equal to 5 volt. Okay. Thus, we found out what is the potential difference between the two terminals of a battery. So, you can clearly understand from the given figure. Let us move on to the next problem. Okay. So, in this problem, we are going to see a battery of 10 volt carries 20,000 coulomb of charge through a resistance of 20 ohm. Find the work done in 10 seconds. Okay. What is that we need to calculate here? We need to calculate work done, W. Okay. So this is the battery of 10 volt and this is carrying 20,000 coulomb of charge. The amount of charge is known and the resistance is given and time is also given. Okay. So for this particular time, this much amount of charge is flowing in the battery. We need to calculate the work done. We know the expression for work done is W is equal to Q into V from the definition of electric potential. Okay. So what is the charge? It is 20,000 coulomb. And what is the potential difference? 10 volt. So having known these two quantities, we can substitute and get what is work done. Work done is 2 into 10 to the power 5 joule. Okay. And you might be wondering why they have given this resistance and the time. Though it is given, we are not considering that. The quantities which are required to calculate the work done is considered. These are all data given to just confuse you. Okay. We shall see the next problem. Third problem. Work done in moving 5 coulomb of charge across the ends of the conductor is 100 joule. If the potential at one end of the conductor is 10 volt, find the potential at the other end of this conductor. Say, this is the end B and this is the end A. So one end the potential is given as 10 volt. So let us have this end, the potential is 10 volt, and we need to calculate what is the potential at this end. Okay, that is what we need to calculate. So we need to find what is VA. Okay, and what is the amount of work done? 100 joule is the amount of work done, okay, in moving 5 coulomb of charge. So given data is work done and charge. So what will be the relation between V, W and Q? We know V is equal to W by Q, but having given only one potential at one point is given, the other point we need to find. So therefore VA minus VB, okay, is equal to W by Q. Okay, work done in moving the charge from this B point to this A point, okay, is what we have to calculate. So VA is equal to, what will be the expression we can get? VA is equal to W by Q plus VB. So let us substitute the values of VB, W and Q. On substituting, we get VA minus 10 is equal to 100 by 5. So VA is equal to 100 by 5 is what? 20. Now that minus 10, it's on the left side. Now we bring on the right hand side. So therefore it will be plus 10. Okay, plus 10. So 20 plus 10 is going to be 30 volt. So VA is equal to 30 volt. Hope you understood. We shall move on to the next problem. An electric kettle consumes 1 kilowatt of electric power if the fuse wire of 5 amps is used. Calculate the voltage required by it. See here, we have been provided with electric kettle. It is having the plug point where it will be plugged to the socket to get 1 kilowatt of electric power. Okay, so power is given and current is given. Fuse wire of current, that is the current rating, has been given 5 amps. So we know I, we know P, and we need to calculate V, that is voltage. So what is the expression for voltage? V is equal to P by I. Okay, from the power expression, P is equal to V into I. So now we have to substitute the value of power. So what is power? 1 kilowatt. 1 kilowatt is equal to 1000 watt, right? So now substituting the value of power and current, 5 amps. Okay, so 1000 divided by 5. Okay, power is 1000 and current is 5 amps. So therefore 1000 by 5 is going to be 220 volt. Okay, let us see the next problem. In this problem, we need to calculate the supply voltage, having given the resistance of the lamp 200 ohm, drawing a current of 1.5 amps. So you can see that here is the resistance of the lamp is 200 ohm and the current drawn by it is 1.1 amps. Okay, what will be the supply voltage we need to calculate? Okay, so from Ohm's law we know that V is equal to I into R. So therefore I, we know 1.1 and R is 200. So on substituting we get V is equal to, substituting and multiplying, we get V is equal to 220 volt. So 220 volt is the supply voltage. Okay, here is the last problem. A charge of 200 coulomb flows through the filament of electric bulb of resistance 20 ohm for 25 seconds. Calculate the potential difference across the bulb. Here, total charge is 200 coulomb flows through this filament of electric bulb having the resistance 20 ohm for time duration 25 seconds. we need to calculate the potential difference across the bulb. Okay. We need to write the expression relating all these terms. We know V is equal to I into R. But we have not been given the value of current, but we have charge and time. We know from the definition of current I is equal to Q by T. So we can substitute that this I value over here, okay, to get V is equal to QR by T. Then we can substitute all the given data. Q is equal to 200, R is equal to 20 and T is equal to 25 seconds. 25 8s are 200. So 80 into 20 is 160. So the potential difference across the bulb is going to be 160 volt. Here are some problems for practice. Please work out. If you like the video, kindly click the like button and share to all your friends. Don't forget to subscribe my channel to get the notification for the upcoming videos. Thank you.